an overall, and then we'll from there circle back into the Treehouse project specifically and how some of those technologies and tools are being deployed for this project.
Perfect, thank you. Well, first of all, thanks everyone for showing up 10 a.m. Friday, which I know most people are not coming to work anymore on Fridays. It's a remote work day, but thank you. And also, I want to thank Roger and Ryan. They came from a distance, and they are tired, and they are here. So I'm excited to be here. I've been working with MGM for the past couple of years. I will show what we have been doing. But our motto has been really simplifying what has been so complicated in the construction industry. As GenX, as a company, we want to be a one-source expertise that would help architects, contractors, and developers. By doing so, we use research, production, and expertise combined, and being able to work all these different parties throughout in different stages of the project. This is me and my team. I have a background 10+ years in architecture after working on high-rise buildings in London, in Shanghai, and New York. I ventured into getting to understanding more issues of construction and design to construction process. That being said, as a service company, our goal is to integrate really know-how of what we do and all different expertise that's needed for different stages of the projects with advanced technology. We understand that there's a gap between integrating those two, and we work pretty much all of these shown phases, and today we'll be focusing more on the fabrication conversation. We work globally. Collaboration is the best way to move forward anything. We have a second office in Istanbul, which gives us flexibility with almost like 24-hour workflow. Like we're able to produce fast, and we're able to also manage our costs. Some of our projects, architectural projects, as you see, they are high-rise buildings. Some of those I was part of as an architects team. Some consultant for architects, helping them move forward the project, manage their team, help them with BIM process, and also manage their consultants to resolve issues. Again, I think we worked in like 7 different, I think it should be 10 countries, but okay, 7 countries and 10 cities. We also do construction projects. This is an area, as an architect, I didn't know much, and we learned so much, and we are continuing to learn a lot. We were so lucky to do projects in New York, like very high-profile projects like Google headquarters, Pfizer building. We either represent GC or the subcontractors, and our role lies with virtual design and construction, which is pre-construction, mainly on the pre-construction phase. We also do infrastructure projects. Recently, we collaborated with Virgin Hyperloop to help them engineer their system for the path, but as well as this infrastructure that will carry that. We do that as a study of understanding what kind of materials we could be using and what will be the construction sequencing. And if this was in US versus in China and India, what will be the material differences and the labor and the construction sequence that we have to think about when we are considering this to be an actual project. And I'm also showing here a project in Istanbul. Our engineering team has plenty of infrastructure projects. Moving to the next slide. There you go. So next, fabrication projects. One project I'm showing here is again with MGM. This is a project where we are helping to develop, coordinate the building and help with the fabrication process. This is, as you may recognize or not, this is a platform we use for CATIA, 3Ds experience. We are testing different tools and applications to see which one is the best for the purpose and the project type, depending on also the schedule and all that. But our goal is always to optimize the process and being able to help each party that's involved in the project to make quick and accurate decision. And again, we will be actually focusing on, Treehouse project, which was highlighted here. I guess lastly, I could mention that given my background with architecture, we work with architects, help them to do CAD-to-BIM transition. I feel like that's a responsibility on us because we see them struggle a lot, and we have developed a strategy that helps them without stopping their projects. We help their teams and also move the project forward. It's extremely important for us to do R&D, and that is one of the reasons that I consider us as an innovation company. We do internal research projects, but we also collaborate with either other companies or organizations like Council on Tall Buildings and Urban Habitat. And we are also working with technology companies, helping them improve their technologies by doing market analysis, give them feedback of their tools, and also helping them see what the future needs will be. Just a slide with the touch base here. One of our research projects looked into all new technologies that are coming into the market. As you will see that you may have heard of them or not, I definitely recommend you to take a look at them. Archistar is an Australian-based test-fit spacemaker, Hyper. You may have heard of those, but majority of those tools are really automating and generatively providing options for early stages of the design, which is actually changing architects' role, given the fact that architects don't need to do conceptual design or feasibility studies. A developer can do those in-house accurately, and architect's role starts afterwards. And as you see, we are showing Odedask and Katia here. They are one of the two major players that can start from conceptual design all the way to do operations and digital twin. And from this chart, we are actually trying to work and service starting from design development all the way to the end. So our research, one of our researches are focusing on understanding the problem of population. This is a study actually we are preparing for, again, Council on Tall Buildings and Urban Habitat, and hopefully we will be presenting this year in Singapore. But basically what we are looking into is the population increase globally. I'm just going to skip through this quickly, but there are a couple points I want to make. Basically what this chart is showing is the population rate shown in the green is decreasing, while the population number is increasing. And the reason for that is obviously people are not having as many kids, and people are living longer, so it's actually the elder population is increasing the number. How this relates to us as an industry, for 70 years we have to meet the need of the housing needs for this increased population, which means that we have to do faster and using less materials, less resources, and also utilizing technology, given the fact that we will have less labor available to this project. And this is where modular construction becomes a valuable solution. I'm going to skip this, but there is all study into looking into whether people are moving into the city centers or urban areas, and that is affecting the construction. That is different for every country. But we actually compare 3 cities, New York City, London, and Hong Kong. We look at their population density versus the build-up area they have taken, the space they are using, and how that is affecting their means of transportation, and that goes back to their energy consumption and potentially embodied energy as well. So the solution we are proposing is that, by mimicry, understanding geometry and how nature is resolving efficiencies and long-term survival. There's this not interesting study, which maybe I should skip, but please look into it, slime molds. Tokyo Metro Trail uses the same nodes for slime to follow, and it's kind of matching to what Tokyo Metro does in a way that that's an efficient path to reach the food resources for this single cell. The second solution to that is mass production. As we know from car production being happening, I think it was like 3 weeks to 90 minutes, like 3 weeks to 3 hours kind of speed, and that needs to happen for construction, and obviously that needs to be prefabrication and modular construction. Another point we want to make as a company is that other industries like aerospace and manufacturing, while their efficiencies and productivity or even profitability increases, construction has been decreasing. So trying to understand that, because while what we do is technically the same, given the fact that of course they have one design that they perfected and they build millions of it, whereas architecture has to resolve the same different problems each time. So maybe the solution there that we need to focus on creating product-based solutions. Again, the fact that the population is increasing, we have to do everything fast. That might be the only solution that we have at the moment. Skipping through this quickly, just we are looking to materiality of these different industries, and we have a lot of in common what we use, and understanding how we could be as efficient. So there are a couple short studies that I like to show using different technologies. In this case, we are using CATIA to test a modular study. Let me, there you go, sorry. Basically, we are using CATIA. I don't know if anyone has ever used CATIA here. Anyone? Well, you? Yes. Another point in you. Okay. So basically, what we did is for example, we created an outline of the site boundaries, and as we are changing the site boundary, the building responds to that with the number of the cores, the corridor that it needs to have, and now we have a variety of modular units that are being placed with the parameters that we are controlling, and we are looking into how to optimize the chassis system, maybe having sort of square corners that to be rounded, and that each parts are editable, so that we could also manage supply chain process and also design to fabrication back to design itself. This is a tool that I think architects could be interested. This is again part of our CATIA tools, Natural Sketch, where you can actually sketch ideas and use those sketch lines, which are vector lines, bring it into your parametric setup, and then go between concept level to fabrication level, and being able to modify them simultaneously, which I think is an architect's dream to be able to do it. Another project I want to show is a facade project that has using CATIA again. In this case, we are working with the architect who gives us their design model as a Rhino, and we are using Excel linking to get the levels, and now we are creating a facade grid system, which we are able to change and see issues of like how many typical, non-typical stair areas. As you see, we have this monitor on the site that we are able to see, but we are able to also put together this library of mullions that are accurate and fabrication ready. And we are also, our facade building was having multiple slanted surfaces, so our mullions can adjust to those automatically, and the geometry is adjusting again, or facade system adjusting to that. So this part is a little bit interesting, so I'm going to stop for a second. We are using automation here to tell, if I'm choosing this panel, place all the appropriate mullions to it. So what it does is it finds all surrounding panels, which is shown yellow here, and based on the angular relationship between our original panel to the side panels, it decides if it's a corner or the top or bottom, or it automatically defines what it needs to be and place the accurate mullions for those. And if some areas are too small, we are able to eliminate that. We say that ignore that area. That essentially we are able to get a very detailed type of units that are coming out of the geometry. This is showing that one floor setup, and we're able to get into like level of detail of both shop drawings and fabrication. Very complex geometry at the corners and all that are being able to manage. So this is, I know, not familiar to most of it, but this is a tool that needs to be explored further, and we are really trying to find ways to make it available for architecture AC in general. So with the platform it creates, actually we're able to communicate back and forth with our teams to kind of keep track of our process. So that's one technology, I think, example that I wanted to show. And I think that is it for our part of that. And what I'm going to show is now I'm going to come back to our board that we put together. The problem, okay, I have to do touch screen. So basically, we do very different type of projects.